everyone, my name is Chakridhar and welcome to this project presentation. Today I am excited to share our capstone project titled as Yoga Asana Detector using deep learning techniques. This project was completed under the guidance of Dr. Burji Kishore Tiwari, Assistant Professor in Department of Computer Science and Artificial Intelligence. I am presenting this project on behalf of my teammates Ajmera A. Pujita, A. Abhilash, K. Pranay, and myself, T. Chakridhar. Abstract of this project. In the in today's digital age, many people learns yoga online through apps, websites, or YouTube. But biggest challenge is that these platforms do not offer real-time correction. Beginners often don't know if their post position is right, which can lead to strain or long-term injury. So, our solution is deep learning based system that detects yoga asana in real time and gives immediate post, po- posture of feedback, just like having virtual yoga instructor. Motivation and background. New yoga practitioners could not tell if their pose is correct or not without a teacher's help. So we suggest using a computer program to check yoga's poses and give feedback. This program uses special technologies called deep learning to recognize poses and alert practitioner if they need to make adjustments. Objectives of this project: recognizing this challenge, a solution has arranged yoga postures optimized using deep learning technologies. At the forefront of this solution is the YNPN MSSD model, which integrates PoseNet and MobileNet SSD. These components plays crucial role in architectural recognizing yoga postures. PoseNet focus on identical keys future point on the body, while mobile net SSD detects humans within each frame, framing the backbone of the system's functionality. Introduction of this project. The combination of technology and science has changed the way we live, work, and connect with each other. This change has made things earlier and faster and has led to new and exciting discoveries in many areas of life. Among these, the integration of technologies into healthcare has been particularly transformative, revolutionizing medical diagnosis, treatment, and patient care. Moreover, beyond the realms of traditional medicines, the recognition of alternative practice such as yoga, humamba, and martial arts and other physical activities as visual components of physical well-being has assigned significant tensions. Lecture survey. Recent studies has explored using advanced deep learning and machine learning models to improve real-time yoga pose recognition and feedback. Researchers tested various deep learning models includes CNN and 3D CNN models achieving high accuracy 98.8% to 99.07% and fastest processing. After optimization, the best model ran on a low power device at 8 frame per second, making it flexible for self-guided yoga practice. Another study used CNNs and yoga for pose detection with log Violo showing supervisor accuracy 92.5% compared to other models, bridging traditional yoga and model technologies to enhance professional practice. Existing systems. Learning yoga in presence of the trainers, yoga centers, learning through uploaded videos in social media platforms, virtual yoga studios. They are the existing solutions for practicing yoga. Disadvantages of existing system. Lack of discussions forums or social features. Poor video streaming quality. Lack of real-time feedback from instructors. Lack of safety guidelines and inequality modifications or adjustments of injuries. Problem identification. Lack of real-time feedback and guidance in online yoga classes about proper pose execution, posing health risk for beginners. Inability to receive immediate feedback on pose, alignment, and execution. Limited visibility and corrections of poor posture and movement patterns. Increased risk of injury. Difficulty for beginners to self corrected and improve their practice. Architecture for posed methodology. Image data to image data collection to image to numerical data conversion. Training the data using YPN MSD, real-time user input, pasting the data using YPN MSD, future point detection for each frame, recognizing correction or incorrect poses. Implementation and results. We collected image dataset and then it is converted into numerical dataset for further execution. We processed the data using deep learning techniques and then the data which is divided into a training is trained using the processed model which is MMSD, MobileNet and PoseNet. After doing all this, we combined the trained results with the React to implement an interface. We can access the interface. It also asks us to allow camera to access and capture the pose. Then user have to select the pose. Then the next step is the user have to read the instructions to practice the yoga pose. Then user have to click on start pose so that user can see the image of that pose on the right side and can do the pose in front of the camera. Then the user performs the correct pose. The skeleton will be a green in color. Otherwise, it seems white color. Here we can see the home page of the interface first. Then second, we will get the pose instruction page. We have to click on the start pose. Here we can see the image which is green color. It is a correct pose and white line is incorrect pose. Conclusion. Proper posture is subtle in yoga and technology, particularly deep learning models holds promise in ensuring correct performance. The model leverages PoseNet for future point detection and MobileNet SSD for human detection in each frame, providing a robust combination for accurate posture recognition. Comparatively analysis with the PoseNet CNN model reveals the supervised accuracy, highlighting the YPN MSSD model's value, not only for yoga but also for desired applications in sports, healthcare, where active recognition and pose identification are currently. Future scope. In the future, the yoga posture recognition application can be trained with more number of yoga poses. Additionally, full-fledged training can be performed to build a fully adapted real-time model for a real-time noise environment to act as a professional yoga trainer. An audio-based alert can be included as the part of the future scope to indicate a signal to the user when the correct position is attended. The PPT presentation has completed. Thank you. This is a poster, Yoga Asana Detector using deep learning techniques. We have the introduction and objectives as well as data usage sets. PoseNet is exerted 7 key points and computer joints angles also. Here we can see the methodologies types. Step 1 data collection, step 2 processing, step 3 person detection, step 4 key point extraction, step 5 angle combination and pose compression, step 6 hybrid model inference interface, step 7 real time feedback generation, step 8 performance tracking. Here we can see there is some references from the others. Let's go on to the code. Here is the code where the training data, it is imported all the sections and loading files and all the sectors. Here we can see the trains also where we can see CNN also. It is starting the training for the computer and evaluating this. Here we can see the data structures of test data and trained data. Here we can see the front end, which is our screen for the first one. The logo for us. This is the backend code for running the project. We can run our code, changing the path, and we start the project. After this, we need to run the project. Yes. If we local host the directly, and then looks like this. Now we have to start the yoga, and here we have to select the poses. We have 7 poses. Let's if we take as a tree and we should click on the start pose, then we should allow the camera. Then we need to give the pose here. Here is the pose, and the right side you can see the accurate pose. Here we should give the poses like it's same, then it gives us. Give the project has completed now.